Hello YouTubers. Headline of today's video is build a Ssb Lap Monitor. To be honest, you can see I have nothing yet but an idea. So if you like, you can follow me through the whole process right from the beginning up to the point where we hopefully have a nice working product, a Ssb Lap Monitor. Yeah, so what is Ssb Lap Monitor? So simply, a Ssb Lap Monitor is nothing else than a demodulator which is able to demodulate a Ssb signal. I mean, I can really do a lot with my spectrum analyzer, so I really can analyze a lot concerning the TX way, the TX path of a radio. So for instance, with a double tone, I can analyze the intermodulation products, which is telling me really a lot about the linearity of the radio, so the TX path, the power amplifier, and I can analyze with my audio spectrum analyzer. I can analyze the filter response, and I can analyze the audio frequency package within the passband, and so I can really doing a lot with my lab equipment. And yeah, you can. I have here for instance. I have a screenshot from my spectrum analyzer. This is, for instance, double tone intermodulation product. So this is a double tone, and here you can see the intermodulation product, which is in this case, don't know if you can see it. It is an ugly screenshot. It is minus 33 dB, so that is really a nice intermodulation product. And I have another screenshot here, and yeah, I know quality is bad. It's just to show you. This is the Ssb filter, and you can analyze here the filter, how it is working. So you really can do a lot with your equipment, but what you are not able to do is simply listen into a demodulated audio signal. So when you put an audio signal into your microphone jack, you want to have at your receive side, you want to win back your audio signal. And as you might know, yeah, we simply start right from the beginning, so we are really in the thinking phase. So if this is level, and this is frequency, so that is F, and that let's say is dBm. So maybe we have here your signal, and let's say it is 14 megahertz, right? So we know from a normal AM signal, so there is the upper sideband and the lower sideband audio signal. So let's say that is 1 kilohertz. So that is 1 kilohertz. So that means your upper sideband is at 14.001 megahertz, and your lower sideband is at 13.999 megahertz. So, and as you might know, that is an AM, so an amplitude modulated signal. In a SSB signal, we know your carrier, which is this sitting in our example exactly on 14 megahertz, will be suppressed. So this is suppressed and therefore not anymore available, just a little bit, because it is nearly impossible to suppress it completely, or only with a high effort, which is not necessary really. So your carrier is gone, and now you have your double sideband. And for instance, if we are going to transmit an upper sideband signal, so we put here a filter. We put a filter over this area in our frequency domain, which is let's say 2.3 kilohertz width, and you can now easily see our carrier is suppressed already by a technique of the balance modulator, how it is called, and your lower sideband signal is attenuated by the SSB filter as maximum as possible. So only your upper sideband signal, which is sitting on 14.001 megahertz. So that is 14 megahertz, and this is our 1 kilohertz audio frequency. And what we want to do is to win back our 1 kilohertz audio frequency signal, and therefore we know we need a demodulator, and the demodulator for SSB works nearly the same as the balance demodulator. So you need to add your carrier, which was suppressed on your transmitter. You need to add it back to the signal, and with your zero beat technique, you can win back your audio signal. So, what does that mean from a block diagram perspective? We need a kind of mixer, which is at least our as demodulator, Ssb demodulator. It is also called product detector, but as I mentioned before, it is very similar to the balance modulator in your TX parse. Your product detector works with two inputs, so that is on one hand your LO, which is your local oscillator, and on the other side with your RF, and at the output, so of this product detector, you have your RF, so your audio signal. And what we want to do is to amplify our audio signal in a way that we can connect a loudspeaker to our audio amplifier, so that we can listen to the demodulated signal, which has been demodulated in our mixer, in our product detector. In here we can, for instance, put an putty to adjust our audio level, so that is volume control for our audio amplifier, and then over some over some switches we will as well have the opportunity to install a dummy resistor of 8 ohm to the system. So for measurement purpose, I can switch to a dummy resistor, which has the same resistor as the speaker. Both should have 8 ohm, and in parallel we will switch as well. We will switch as well a connector, a BNC connector, where we can connect some measurement equipment to it to watch the signal. Well, so our mixer here is what I'm looking for is something which looks like this. So that is a bit like this. So we have here a transformer, which is no, that is not going to ground. So you see that is really thinking about a project, about the circuitry. So that is development, kind of, if you like. And the circuitry should be something like this. So these are diodes connected in this way. So this is not a rectifier, so that looks like a balance modulator. And so then we have here the output, which is going on a coil as well, and we connect this to here, and here we will have at least our audio frequency, and then we will have a second, so that is a transformer as well, and we have two inputs here and there. So this is local oscillator and this is RF, and we have here so that is the output. That will be our pure AF audio frequency. So that is what should be in here. So that is the mixer what I'm looking for. So I could build it with coils and diodes, but what I really want is a nice and stable working circuit, and therefore I have to look at a manufacturer. I guess it is a good idea that I look through mini circuits. So they really doing nice RF components. So I hope that I will find something on the mini circuit website. And for the NF amplifier, so it should be simple as possible as well. One chip should be enough. We do not really need a high. We do not really need a high volume. So what we minimum need, so that is the requirement, is an output of 50 milliwatt. And why do I say 50 milliwatt? So that's very simple. 50 milliwatt, and you might believe it or not, but 50 milliwatt is really called as room. How do you call it? It is room volume level. So if you listen to music on a room level, it is, you do not really need more than 50 milliwatt. So that is a nice level. It's a nice volume level where you can easily listen to whatever, music or speech or whatever you like. So 50 milliwatt is enough to drive this speaker. So that is a requirement, the minimum requirement. And yeah, we need our voltage. So that should be somewhere between 5 and, let me say, 12 volt for the amplifier, and for the mixer. Both should work within the range of 5 to 12 volt. And yeah, so what can I say so far? So that is nearly the complete idea of the project. So I haven't really told you the truth, because what I already have is this nice housing. So that is something which I had already in my store, and so I guess that is nice. So the only thing we need to do, I have to cut out a new front panel, which we put here on the front, and we can put the PCBs right into here. So we need as well a little power supply, which is supplying 5 to 12 volt. So I can also put some voltage regulators in between. So that is where I have to look what I maybe have in stock. So I guess I have a little power supply already. So that will be next step to see what we have. And I also think I have already an audio amplifier, so I should have at least a component which may fulfill these requirements. I should have it somewhere here in my magazine. So let me see. Must be a LM. Look here. Here it is. I have a LM 386. So this is a little. So that is a little amplifier. It is nothing special. Yes, guys, I know I need a tripod. I promise I will organize one. So this, yeah, you can read it. This is an LM 386, and as far as I remember, this is a little audio amplifier which might fulfill this requirement. I mean, there is a second requirement. It is not only the 50 milliwatt what we need as drive. So what we need as well is an audio amplifier with low THD. So that is a second requirement. THD is total harmonic distortion plus noise. So that is how it is normally defined. And so you know, the RF, the audio frequency stages in radios, in two-way radios, are somewhere between 5 and in worst case it is 10, something like that. I mean, 5 is not really bad. Our old tube radios did also have something around 5% THD. So we should be at least a bit better than 5 or 10. So requirement should be let's say between 2 and 3% THD plus noise. So that should be the requirement, that our signal is clean and pure enough that what we can finally hear on our speaker is really that what the transmitter with the complete signal path up to the microphone, the microphone preamplifier, what have we all what is really in the signal path until the radio frequency with the modulated 1 kilohertz on our radio frequency signal is leaving your radio. So that is what you want to analyze when you receive it back, and when you make it hearable in a speaker like this. So should not produce more than 2 up to 3% total harmonic distortion and noise. So that is, I guess, another requirement. And yeah, next will be to look up the datasheet for this little audio amplifier. Then next will be to build it on the breadboard and check if we can drive a speaker, and check if we really able to reach at least 50 milliwatt, or better more than 50, let's say 100, but minimum 50. And we have to check if you are able to reach our requirement of 2 up to 3% total harmonic distortion. So that is next. So looking for the data sheet that we can build a test circuit on breadboard, and I will check on the mini circuit page if we find at least a mixer which is fulfilling our requirement. So yeah, normally if you would use it as check monitor, you need a local oscillator in your housing, right? You could easily take a quartz oscillator sitting on a specific, let's say 80 meter band frequency, and then you can adjust your RF to this frequency, and at the output you will have your audio frequency as well. So that is something you have to add if you want to use it in your check. In the lab it is a bit different, because as local oscillator I will use my wave station, so my signal generator, which can supply all the frequencies I need within our amateur radio band, and therefore I will only put an BNC to the front panel of the project, where I can connect my wave station, my signal generator, to it, and adjust my wave station to the frequency I need. So let's say our 14 megahertz. So here we would feed in our 14 megahertz, and RF in our example for upper sideband was 14,001 megahertz. So that will be our RF signal, which is coming from the device under test, so from the transmitter, and at the output of the mixer we will then hopefully have our 1 kilohertz signal pure and clean, and then we will amplify it pure and clean, and hopefully we can then listen it and then hopefully we can listen the 1 kilohertz in our speaker here. So that is the plan. And okay, one question you might ask: why do I not simply set up a lap radio to have a test receiver? Yeah, you are right. So that is what I'm currently doing. But to be honest, bench space is very rare, and it is much more easy to have such a nice little device on the bench, as well with a dummy load integrated. And I will see if if I can switch different gains. So if I really coming in with a very low level RF signal, I need certainly a higher amplification than if the RF signal is already strong. So that is something I need to investigate. And yeah, so far that is a plan. So as mentioned before, next will be looking or searching the datasheet for my LM386, then looking on the mini circuit website for a solution of this mixer, and yeah, if we then can build this on a breadboard, we are moving forward. So now we have the plan, and let me look out for the datasheet, and then I can continue the project.